We all know interpreter is a software which executes line by line. That's very good. We all know that. But we should also know the internal part. How does interpreter work? That is very important. So first we'll understand what is machine code and what is source code. Okay, so before understanding interpreter, we need to understand what is machine code. So to understand what is the definition of machine code? So we're gonna see what is the definition of machine code. Machine code is also known as object code. It's also known as object code. It is a set of instructions. Okay, it is a set of instructions directly executable by the central processor unit of the computer. Okay, it is directly executed by the CPU. Okay, so machine code is an object code, is also known as object code. It is a set of instructions executed directly by the CPU. It is executed directly by the CPU. Okay, now what is the format of the machine code? The format of the machine code is in the zeros and ones. Okay, it is in zeros and ones, that is the binary format. Okay, and is it human readable? No, it is not human readable. Okay, it is a low level language. It is a low level language which only machine understands. You can't understand zeros and ones, right? What you have written. So it is not human readable. Okay, it's not human readable. Now, so platform specific. Yes, it is platform specific. Machine code is specific to the architecture of the CPU. Now, machine code is dependent on Windows. Machine code is dependent on Linux. Machine code is dependent on the Mac operating systems. The three are different. Okay, you can't bring the machine code of the Windows and you can't put it in the Linux operating system. It doesn't work. So you need to understand that yes, machine code is platform specific. Here we are referring platform as the operating system. Okay, now let us see few examples. Examples are AMD processors and ARM based processors. Okay, examples of machine code are AMD processors and ARM based processors. So as we spoke about machine code, now we'll talk about source code. So we have seen machine code is in zeros and ones. It is only understood by the machine, right? Source code. What is source code? Source code is a human readable language like Java, Python, C++. We understand that, right? We as programmers understand that. So the set of instructions understood by the programmers is what source code means. It's a high level language. Okay, coming to format. Format can be in form of syntax, keywords, conversions. It's specific to the language. Java has its own syntax, C++ own syntax, Python own syntax. So it will be in that format, whatever the syntax is specified for that language, right? Coming to human readable, yes, it is human readable, and we all know we can read hash include stdio.h in C, public static void main in Java. We can read it as programmers. Now coming to very important point, platform independence. We have seen machine code is platform specific, but here platform independent means the source code we will write once and you can run that program, the source code, in different platforms. You write a program in Windows operating system and you take the source code and you can use it in the Linux. So in different operating systems, in different platforms, you can run the same source code. So that's why we call write once, run everywhere. Okay, that's very important. Java is write once, runs everywhere. How Java is platform independent, what is the significance of JVM, we will talk in the next coming sessions. Okay, so source code is platform independent. It's not dependent on the CPU. It's not dependent on the operating system. Okay, you need to understand that. Examples: Java, Python, C++, all the programming languages, we know that. So those are the examples of source code. Now we will understand what is interpretation. We'll understand what is interpretation, how does interpreter works. So before understanding interpreter, we are seeing here this side is the flow of the program execution of a compiler language, and here it is the flow of execution about the interpreter language. Okay, so in compiler language we can see we have two steps here: compilation and execution. Compilation and execution. Now here in compiler language, source code is given to the compiler and it is compiled and it's converting into machine code. So source code is first converted into machine code, and machine code as the set of instructions is given to CPU. We have seen machine code, right? What is machine code? Okay, and it is platform specific. So the machine code is platform specific to the CPU. Okay, it is dependent on this CPU. If the CPU is about Windows, this machine code is specific to this Windows operating system. So the set of instructions is in the form of machine code, that is zeros and ones, and that is given to the CPU, and CPU in turn executes and gives the result. Okay, here if you come to the interpreter language, okay, if you come to an interpreter language, directly the source code is given to interpreter. Okay, there is no compilation and execution step happening here. Okay, it is, this one is totally working differently than this. There is no compilation and execution step. Okay, source code is given to interpreter. Note here that interpreter is a software, it is also a program. So indirectly interpreter uses CPU. Indirectly interpreter, a program should run, right, and it uses CPU, it should have memory, it should run, right? So interpreter will eternally use CPU. Okay, and but the result is given by the interpreter. Okay, so for an interpreter, source code is the input and this interpreter gives the result. Okay, so this is how you need to understand the difference between compiler language and an interpreter language. Now let us understand the technical aspect of interpreter. Now interpreter, we know source code is given to interpreter and interpreter will give the result. Now interpreter is a virtual machine. It is a virtual machine. Virtual machine is which is not physical. Now if you tell only machine, it is CPU which is physical having an operating system, but virtual machine is something, a software, okay, which is sitting inside the main machine, that is CPU. Okay, so interpreter is a software or a program, okay, which is a virtual, which acts as a virtual machine that simulates a CPU. Okay, it is simulating like a CPU. So next we see that in the compiler language, machine code is given as an input, right? Machine code is given as an input and CPU has executes that machine code in a fetch and execute cycle. We will see what is fetch and execute cycle. Similar way, even in an interpreter language, fetch and execute cycle happens. Okay, don't get afraid about what is this. We'll definitely see this, what is fetch and cycle, in a brief manner in the next coming session. Okay, here we are talking about CPU's fetch execute cycle. We also will talk about interpreter's fetch execute cycle, but CPU's fetch execute cycle is a fundamental concept of a computer. Okay, every developer and engineer should know about how CPU's fetch execute cycle works. Okay, we have three components, that is CPU, memory and hard disk. Okay, in fetch execute cycle we have CPU, memory and hard disk. So we have a program here in the hard disk. Okay, that program is set of instructions. Okay, that program is the set of instructions. Okay, and it is given to the memory. Okay, the machine code, which is a set of instructions in binary format, that is zeros and ones. Okay, so program is given to the memory in the form of zeros and ones. Okay, in turn the memory sends the information. The CPU will fetch the instruction from the memory. The CPU will fetch the instruction from the memory. Okay, and will execute here. Okay, the fetching is happening here from the memory. Okay, we are talking about instruction, a single instruction. Okay, a single instruction is fetched, okay, and given to the CPU, and CPU executes. During execution you need data like variables, blah blah, etc. Okay, so during the execution data is also fetched simultaneously. So once that instruction is fetched and executed by the CPU will store the execution in the memory itself. Okay, so this is how the fetch and execute cycle works for a CPU. Here we are talking about CPU, so the instruction program will be in the form of machine code. So you should note that we are not talking about high level language, we are talking about the low level language. A machine code is given instruction, fetched, executed and stored in the memory. Okay, so this is how CPU's fetch execute cycle works. As we see in the CPU's fetch execute cycle, the instructions from the memory is given to the CPU and the CPU executes. But when we talk about interpreter's fetch execute cycle, the similar thing happens in the fetch step. Okay, from the memory the instructions are given to the interpreter. Okay, but here the instructions is in the form of program statement, that is source code, not machine code. In CPU the instruction is in the form of machine code, but here the instruction is in form of source code. The program statement is given from the memory to the interpreter. Now how does the execute happen? Now the interpreter is having the instruction, the source code statement. The interpreter will first understand the statement, understand the source code. Okay, then the interpreter will get the corresponding pre-compiled machine code of that source code. You got a statement, suppose the statement is add. Okay, that is what we are getting from the memory to the interpreter. The interpreter is having a library of pre-compiled machine code with it. So we are writing add. That add is we get from the memory to the interpreter. That corresponding precompiled machine code is fetched from the library, and then the execution is happened. Now we will look at an example of the execution step of interpreter's fetch execute cycle. See, we have an source code that is known as add statement. Now this is fetched from the memory into the interpreter, and the interpreter will indirectly get the precompiled machine code. Okay, it is not taking the machine code. In CPU the machine code is given as an input, but here the source code is given as an input from the memory to the interpreter. The interpreter indirectly from its library it will fetch the machine code. Okay, the pre-compiled machine code. You can say the interpreter will fetch the add statement pre-compiled machine code from its library. Okay, that is, see, it will take 2 operands from the memory. Okay, it will put it in the stack, and then the result is fetched from here, and it again pushes it into the memory. Okay, don't think about what is stack, what is pop, push. Okay, just think that it's just a set of instructions of the machine code. Okay, so this is again given to the memory. Okay, here interpreter is not generating any machine code. You need to understand this point very clearly. And now we will talk about platform independence. Okay, we'll just give a brief. So we have seen the fetch execute cycle of the interpreter, okay, where the source code is given as an input. So this source code can run in any of the operating systems. It can be Windows, Linux, Solaris, and any of the operating system, irrespective of the operating system, irrespective of the machine configurations. This source code can run. That is, source code is platform independent of the operating systems. But when we talk about the CPU, that is a compiler language where machine code is given input, but machine code is platform dependent on the machine. Okay, the machine code is platform dependent on the Windows operating system, so that can only run on the Windows operating system. You can't take that machine code and run on the Linux. But here you can take one source code and run everywhere. Okay, but you need to note that every operating system should have its own interpreter installed. Okay, so when we talk about Java platform independence, we will more clearly talk about JVM, okay, which is also acting as an interpreter. Okay, so you need to understand, when we talk about CPU, that is compiler, Java is known as write once run anywhere concept, comes from this concept only. You need to understand that. So we will talk about the pros and cons of interpreter. First we'll talk about the advantages. Okay, you can get this question in an interview. Okay, if you're a fresher or an experienced, they will ask what is an advantage of an interpreter. So you can add these 3 points. Okay, first one is platform independence. We have already seen the whole explanation how it is platform independent. Okay, and next is no compilation step. Okay, this is something very unique in interpreter, where you need not to compile, directly execution happens. It directly the code is executed. Okay, now third is easier to update. For example, if we take a JavaScript language, it's an interpreted language. Okay, and the code is written in the JavaScript language and it is in the production server. Now there you found a bug there. Now you need not to fetch the file again, compile and execute. Since JavaScript is an interpreted language, you can update the bug, you can write the code there itself and execute in the production server. But if it would be a compiler language, you can't do that. You need to get the whole code again into another separate file. You need to make changes and you have to remove the error, compile it and execute it. We have seen CPU fetch cycle, we have compiler and execute step. That you need to do every time when you find an error, and that takes a whole lot of time. Okay, so this is one of the advantage of the interpreter. The limitations or disadvantages of interpreter. First is it is slow. Why it is slow? Due to costly memory access. The memory has to include all the program statements in it. But when you talk about compiler language, it runs through the registers. So when registers are used, it is 100x times faster than interpreter. Okay, so this is one of the disadvantage of interpreter. Second is source code is reinterpreted every time. Every time there is you're running the program executed, the whole source code is reinterpreted again and again. Okay, that is another disadvantage. Third is interpreter is loaded in memory along with source code. We all know that interpreter is also a source code that is also loaded with the source code which we are writing in the memory. Okay, so which takes a lot of memory, right? So this is also one of the disadvantage. So we will see in future how Java solves these issues, okay, without compromising on platform independency. Thank you.